In this example, we've been given two graphs, g, which is a linear function, and f, which is the quadratic function, and we're being asked to find composite function values and also combined function values. So looking at A, we have g of f of 3. So the f is inside, so we're going to start with the inside function f, and the input of the f function is x equals 3. Our y value for that function is going to be at y equals 7. So f of 3 equals 7. We're going to use that 7 as the input for the outside function g. So essentially what we're looking for is g of 7. So to find g of 7, we go to this value x equals 7, and then we look at the y-coordinate of the red function at x is 7, and it looks like the y-coordinate is going to be negative 1 over 2. So we start with the inside f, and then go to the outside g. For b, we're going to use the g value at 2 and the f value at 2, and then we're going to subtract those values. So the g value at x equals 2 is going to be y equals 2, and the f value at x equals 2 is in the same position. So what we end up getting is g of 2 is 2, and we're going to subtract the exact same y value from the f function, and so we're going to end up with g of 2 minus f of 2 is going to give us 0. Where those two graphs intersect, the difference is going to be 0. For c, we have a combined function by multiplication at x equals negative 1. So again, we're going to work out the y value of g at negative 1. It looks like it's 3.5. So we end up with positive 3.5 times. We work out separately the f value at negative 1. The f value works out to be negative 1. So working those two out, multiplying them together, we get negative 3.5. For d, we have a rational function. And when we're dealing with rational function, we want to know the domains. So the domains of f and g are all real numbers. However, in the g is in the denominator. We cannot let the denominator equal to 0. So g of x cannot be equal to 0. Well, 0 happens at that point right there. So our restriction then becomes that x cannot be equal to positive 6. For e, we're starting with, again, a composite function. So we have an inside and outside function. The inside function happens to be the inverse. Now, it's important to remember that the f of x, the original f, goes x to y. The inverse functions go from y to x. So I'm going to start with the inverse of g. So that means I'm looking for a y value of 3 and to get an x value for that g function. So I'm going to go to my red graph and I'm going to look for y equals 3. Y equals 3 happens right there at x equals 0. So what we're going to end up with is the g inverse g of 3 works out to be 0. That becomes our input for our f function. Now the f function is going from x to y, so we're just going to plug in x and get y. The y value from the graph is going to be negative 2.